All right, welcome to this episode where we're looking at the review questions from chapter 15. So we're looking from a textbook on page 338. We're going to go through these questions so you get a better understanding of the topic of work and power. Right? So question 1 says, a tractor pulling a plow exerts a drawbar pull of 7.5 times 10 to the 3 newtons over a distance of 3.2 kilometers. If it has a power of 25 kilowatts, how much time does it need to do this work? So the information that we have, let's see. Oh, no, we want pencil. Make it a big size. So we are given the following information. 7.5 times 10 to the 3 newtons over 3.2 kilometers and a power of 25 kilowatts. So they want to know the time. So we need to figure out what the formula is that we're using for power, right? So we're given power. So power we know is equal to work over time. And work, we know the formula is to be force times distance times cos of the angle. Now we are going to make an assumption that there is no angle because it doesn't give us the angle in the question. So we will say work is equal to 7.5 times 10 to the 3 newtons times 32 kilometers is 3,200, 3.2 kilometers, 3,200 meters. So then if we multiply them, we get our work to be 2.4 times 10 to the 7 joules. So now that we have the work, we can figure out power equals work over time. So therefore, time equals work over power. So our time is equal to 2.4 times 10 to the 7 over 25,000, right? Joules over watts. So we end up with our answer of time is equal to 960 seconds, which is 16 minutes. Okay, number 2. Different color, just different. Number 2 says, it takes an elevator 2.5 minutes to climb from lobby to the 10th floor of an apartment building. The tenants have asked the landlord to increase the elevator's speed. The landlord responded that if the elevator went faster, it would perform more work and consume more energy. Is the landlord right in your answer? Well, let's see. Work. The landlord says it would perform more work, consume more energy. Work is equal to force times distance. There is no time factor. Power, however, has work and time. So if we're talking about speeding up the elevator, we're not talking about greater amount of work. We're talking about greater amount of power, right? So because we're changing this element, we're not changing this, and we're not changing this. It's still the same force being pulled. So therefore, it is not true. The work is the same, regardless of because the weight of the elevator has changed. All right. Number 3. A 5 Newton force is causing a 6 kilogram object to move on a rough horizontal floor at a constant velocity of 2.5 meters per second. So again, constant velocity means that we have a standard force. The force is parallel to the floor. Calculate the work done in 25 seconds. So we have 5 newtons. The mass is 6 kilograms. And the velocity is 2.5 meters per second. Okay, so we want to know, so it says, what is the work done for 25 seconds? Calculate the work done in 25 seconds. Okay, so the first thing we should do is we figure out, use one of our older equations. So we have velocity we know is equal to displacement over time, right? Therefore, we can rearrange that to be the displacement is equal to velocity times the time. So if we have the velocity is 2.5 and the time is 25, we can get our displacement of 63 meters. Right, 2.5 meters per second times 25 seconds is 63 meters. Now that we have the meters, we can figure out the work is equal to F times the displacement, so 5 times 63, and then there's no cos of the angle because it is horizontal, so it's 315 joules. Okay, that's part A. Part B says, what is the power generated? So power is equal to work over time. So we have the work is 315, and we have the time is 25 seconds, and therefore divide the two and you get 13 watts, right? C says, what is the magnitude of the force of friction that opposes the motion? So what is the F? Now, because the velocity is constant, right? The question says it's constant velocity. Therefore, the FF must equal the F. So therefore, 5 newtons. Otherwise, it would speed up or slow down. All right? Number hey, number 4. New page. New page. Don't save. Number 4 says, an elevator and its passengers have a mass of 1,300 kilograms. So 1,300 kilograms. Let's write that down first. The elevator's engine causes it to rise to the 12th floor in 75 seconds. So 75 seconds over a distance of 40 meters. So 40 meters. So we have our mass, we have our time, we have our displacement. They're asking us, calculate the work done. So A says, what is the work by the elevator's engine? So if we're solving for work, all we need to know is the work is equal to F times displacement because it's going vertically. So the force. Now, how do we find the force? Well, we're talking about 1,300. So F is equal to mg because we're going against gravity, right? So we have 1,300 times 9.8, and that gives us a force of Fg, which is equal to F, gives us our answer of 1.27 times 10 to the 4 newtons. So as soon as we have the newtons, we can now go 1.27 times 10 to the 4 times displacement, which is 40 meters, and it gives us our work is equal to 5.1 times 10 to the 5 joules. Okay. Part B says, what is the power generated by the elevator? Well, so power is equal to work over time. So we have 5.1 times 10 to the 5 over 75 seconds gives us an answer of 6.8 times 10 to the 3 watts, or 6.8 kilowatts. All right, change color again. Number 5. A chairlift is transporting skiers to the summit of a 300-meter mountain. So 300-meter mountain. The average mass of a skier, including equipment, is 80 kilograms. The chairlift can transport 3 skiers to the summit every 30 seconds. So 30 seconds. So this should actually be times 3, which is 240 kilograms every 30 seconds. So then the question says, technically, a ski lift goes like this, right? But the amount of effective work that is being done is getting the skier from down here to up here. the horizontal distance is irrelevant, right? So the amount of work that's being done is transporting them up. So the lift will do the same amount of work pulling along this axis or pulling along this axis. Okay, so therefore our force is actually equal to mass times gravity. Okay, so we have 240 kilograms times 9.8. That would be our force. So our work, right? It says, oh, determine the power. So question 1 says determine the power. Well, that's a terrible question mark. So determine the power of this ski lift. Well, in order to determine the power, we need to know that power is equal to work over time. In order to find work, we need work equals force times displacement. So our force, F times, we have 240 times 9.8, and then we multiply that by 300. So 240 times 9.8 times 300. So that's our work. Okay, and then to find the power, we just take 240 times 9.8 times 300 divided by 30 seconds, and we get our power to be 2.4 times 10 to the 4 watts. Now the key is to understand that this is all that matters in terms of the displacement, and this is where you get your force from. Just the fact that the lift is going from here up along the incline is irrelevant. How far you go along the horizontal axis is irrelevant, because the whole point of the ski lift is get you to the top of the hill this way. All right. So that's probably going to be the confusing part there, is to negate that part of the question. Right. Part B says if friction increases the power required by 25%, what power must the chairlift generate? The chairlift engines provide. Well, then we just increase it by 25%. How do you increase it by 25%? So 2.4 times 10 to the 4 plus 25% of that. So times 1.25. And that should give you 3.0 times 10 to the 4 watts. Right? Okay. New page. Now number 6. New page. Don't save. Number 6. A student is pulling a sled at a constant velocity with 60 Newton force. So 60 newtons is our force. The sled's rope is not parallel to the ground. There is a height difference from one end of the rope to the other equal to 90 centimeters. So it goes like this. So this part here is 90 centimeters. What is the quantity of work done by the student if he must travel a distance of 400 meters? So 400 meters. Right, so this is the person pulling. And then there's his lazy friend sitting there. Okay, so they want to know what is the quantity of work. Work equals blank. Now, if we know that this is 90 centimeters, and we know that, what else do we know? Oh, it doesn't say in the question, but in the picture it gives us that this is 1.5 meters. Tells us that the length of the rope is 1.5 meters. So we need to figure out, so it's on the snow. We need to figure out what the angle is here if we know that this is 90 centimeters off the ground and this is the length of the rope is 1.5 meters long. Okay, so how do we figure it out? Well, opposite over hypotenuse is, so opposite over hypotenuse should be sine, even though I wrote cos on there. That is an error. It should be sine, and if you do sine, you get the angle of 37 degrees. But now we have the angle, so we have the force is equal to 60 times the sine 30. Oh no, cos. Sorry, cos of 37. Cos of 37 degrees. And we know that work is equal to force times displacement. So we have 60 times cos of 37 times 400, and we get our work is equal to 1.9 times 10 to the 4 joules. Okay, and last question, number 7. A car with a 2,000 kilogram mass is traveling up a slope at a constant velocity of 90 kilometers per hour. So 2,000 kilograms, 90 kilometers per hour. The air resistance opposed to this motion is, so force of friction, we'll call it 450 newtons. The slope forms an angle of 6 degrees, so theta is equal to 6 degrees with respect to the horizontal. So a quick diagram would look something like this. Boom, boom. So 6 degrees against is 450. Here's the car. Gravity pulling down would be 2,000 times 9.8. And then the velocity is 90 kilometers per hour. So that's all the information that we are given. On a diagram, represent all the forces acting upon the car. So here's what we have for the forces acting upon the car. We have the force going forward. The force going forward. Forward force. We have the wind resistance going backwards. Force of friction, wind. We have the Fg. We have the Fn. And that's it. Right? B, part B says, calculate the force exerted by the engine to maintain the car's velocity. So in order to maintain the velocity, you're not speeding up, you're not slowing down, so therefore there is no change in velocity, therefore it just has to be balanced, right? The whole diagram has to be balanced. So Fg is this way, so we have to figure out what is the Fn, pulling back at it. So we have to add the 450 to the Fg, which is 2,000 times 9.8, but we also have to times that by sine of 6 degrees because that is the actual force this way, right? So then we get 2.5 times 10 to the 3 newtons. Right? That is how much force is needed to pull that car up. And then part C. What work is done by the car's engine in 5 minutes? So work is equal to force times the displacement. So we have, what's our force? 2.5 times 10 to the 3 times our displacement is, what is our displacement? Oh, we need to find it first. 90 kilometers per hour times how long? 5 minutes. Times 5 minutes. So do your conversion between hours and minutes and kilometers and meters. And you should get 7.5 times 10 to the 3 meters. So 7.5 times 10 to the 3 meters. And the work is 19 times 10 to the 6 joules. And then last part, D, says, What is the power generated by the engine? So power is equal to work over time, 19 times 10 to the 6 over 7, no sorry, not 7, time. 5 minutes is 300 seconds, so it equals 63 times 10 to the 3, or 63 kilowatts. Right? There you go.